Welcome to Embedded Internals. This is our first episode of our series, Execution Awareness Series. This series is of 10 episodes in which we are going to cover how we write a small C program. After writing the C program, what is the life cycle of that program, how the program goes through all the compilation steps, how the program switch from user to kernel module, how a simple C source code file get its memory, what all steps it goes through from starting from writing a simple code to each and every steps from uh, writing to execution to termination of the code. What all steps has been involved by the user level, by the system level, by the kernel level, device driver level, and at the end hardware level. We will observe each and every step and each and in the one in the subsequent series. But this is the first series, so we are just writing our very small C program. I will show you how a small C program, which we think is just printing a statement on the screen, is actually touching the every part of operating system. It's touching whole operating system, not just you write a command or it print the output. What all steps going behind the scene, we are going to look into it. In the further episodes, we will going to cover each step in very detail. Each step is dedicated to one episode, so please stay tuned for this episode. You will get to know how a small program, or you will get to know for definitely for sure how an operating system operates for each and every program. Taking a very small example of our own everyone's favorite program, that is to print hello world on the screen. Let me explain this statement. This is to tell the preprocessor directive to include a header file named as stdio.h from the standard library location. What this header file stdio.h contain is actually standard. Stdio.h means standard input output header file. This contain the definition of scanf, printf, and all the input output commands, which input output library functions which are required by the program. So this is a very important header file which almost every source code has this header file, because any program you can take, any source code you can take, you have the print and scanf statement. So to include those library functions, we need to include the corresponding header file. And after that we are calling int main. Int main is first first function to run to execute by the compiler. We will in the coming episode we will see that how the main function got invoked, which is the first function inside the kernel who invoked the main function at the user level. Int is the return type of this function. It is returning back success or failure, whatever the status, to the operating system. Curly braces start and end means the scope of the function or the body of function from starting to the ending point. Now we have to print one statement. So printf, whatever you need to print, we are printing hello world. Welcome to embedded internals. And we are returning 0, that is success to the operating system. This semicolon at the end of both two statement is to state that it is end of the statement. Semicolon means end of the statement. So this is a very small simple C program to print hello world, to print any statement over the standard output. Standard output in our cases are shell. So you write the program. Now we need to compile the source code to get the desired output. And to compile, we have a standard Linux compiler GCC. So GCC hello world.c, you compile it and we will get the standard out file, which is a.out, that is assembler out. Now what is a.out? Or we can rename it by any name. A.out is an ELF file. And what is ELF file? ELF file is actually executable and linkable format. This is a structured data file completely which can be loaded directly by the loader into the RAM. ELF file have all the detailed information whichever is required by the loader to load a function, to load a file into the RAM, whereas this hello.c is simply a source code. It does not have all the necessary information. It is a user file, simple user file on the disk. When that file got converted into ELF format, then only we will able to load that into our RAM, into the memory. So we can say that it is a structured binary format. I will show you how we are going the ELF file. So a.out is ELF 64-bit LSP pi executable, and it is dynamically linked, and they are the corresponding libraries through which it is linked, and they have some magic numbers or the identity. So when you see from where these libraries got included into this, so what are the dynamically linkable library? So let us show. This is so.2. This is coming from libc.so.c, which is a C library, glibc library. So we see that a.out is an ELF file. Let me show you the format of hello world.c. Hello world.c. So this is a C source code and it is written into this text format. So these two are this. So what happened when we run the gcc command, that it got converted into a.out file with the steps, intermediate step gcc hello world.c has gone through to give the a.out output file. So before running the program and checking the output, I will show you. We will cover an entire episode on the compilation steps, but just to give you a simple idea, we have written, I hope you all got the program which each and every statement is doing, what is hash, what is include, this and everything. So the second step is to compile the code. So when you give the command gcc hello world.c, this is a C file you have given. So the C file goes through preprocessing directives, preprocessor, which got it converted into .i, where all the header file and every definition, all the header files got included. Now .i will go through compiler. We will get .s file. This .s file, which has the assembly data, assembly output, will get further through assembler. We will got .o. .o is object file. Object file means now this is very close to the machine code, but still that libraries has not been included. So linking is still pending. Other than that, this is complete machine code. So now the .o file will get through linker process, where libraries are dynamically linked to it, and after the libraries got included, we get the a.out, which we are seeing that a.out means assembler output, which is our ELF file. It is a structured binary format which can be directly loaded to memory. Now, what happens when you load this ELF file? To load this ELF file directly, we have to run a command, that is we have to directly run a command /a.out. So when you run /a.out from the terminal or from the shell, a new process is created. And uh, and the process is replaced by the our file a.out to run this program. Once the program start running, kernel allocate the sufficient resources. Whatever resources it will require, kernel will give it. Resources, when we say, it means kernel will allocate memory, file descriptors, it will give the scheduler time to it. So CPU scheduling will be done to this program. And whatever is the runtime behavior, runtime. So once the program start running, kernel allocate the every resource whichever it is required by the program done the execution. After the execution, I mean after the running, not only your program but cell, kernel, memory manager, CPU for scheduling, and the library function libc got called. Libc, we have used the print statement that to call the library glibc library function, and that further will call the kernel, ask the kernel to provide the service of printing a statement on the shell, on the standard output. And then kernel will, on the behalf of user, execute that function and print our statement over the standard output. So printf is also not magic. It has a chain of functionality, change of system calls which get invoked. Now we have a dedicated episode on this. We will cover that in detail. We have seen all these things. Now I will show you this in the terminal. We have to run /a.out. This statement will run our code. Let's see what is happening at this statement. Oh, all these things. Now I will show you. At the shell, you give one command. Command is to trace this. execv system call is called. Execv replace the process by a.out. Whatever the ELF file you have given, it got replaced by this. And after that, some memory has been allocated, some access has been checked, some library etc caches has been called. Similarly, the libraries has been called, open, memory allocated corresponding to that. See, lots of things are happening. Finally, addresses has been provided, memory protection has been provided. Whatever is not required, stack limit and stacks is a memory segment that has been provided to the small C program. Every kernel has provided every resources whichever is required. And after that, it called the write system call. Whatever statement you have given inside the printf, we are seeing here in the write. So printf inside the kernel got converted into write, as printf is a library function part of glibc, it does not have direct access over the kernel. To get to for the kernel to now the kernel execute on the behalf of user function. So when you call the printf, it asks the kernel to perform some operation by using the glibc library, and that is converted by the system call inside the kernel. So there is a switch from user mode to kernel mode for the operation to be performed. One means standard output. Standard output is our shell. So the write system call will perform the write operation to print statement. And finally exit with 0, this is a return statement. So your source code will go through all these things when you give the run command. Okay, so now you understand how the print statement is getting printed, what all memories, what all resources has been allocated to your program. So now just run a.out. You get the output on the screen. Is actually touching whole operating system from user level to the kernel level. It is touching shell, kernel, memory, manager, CPU, libraries. Understand that printing a statement is not some magic. Kernel is doing lot of tasks behind the scene, but as we have a very fast processing system, this takes a few nanoseconds, so we don't that yeah, hello world is not a simple program. It is the smallest example of the entire Linux execution model. I hope you understand how this small C program is actually invoking whole operating system. We have written the program simple C source code file, and that get converted into the ELF file. ELF is a binary format of structured data of binary format that get loaded into the memory, and we run those ELF file and get the desired output. And whatever is happening behind the scene, we also try to understand at the upper level. So our next episode will be life cycle of Linux program, where we are going to cover what is program, what is process, how the process is created, what are the different states a process is assigned, what are PIDs, PCBs, scheduling pieces, how a program gets scheduled by the CPU inside the kernel for the execution. So from the how the program got created or born to how the program got terminated, we are going to see each steps, intermediate steps in between birth to death of a program. Stay tuned. Thank you.